Today, Mitja Jančič will speak about ballooning. Ballooning? What does have the ballooning do with paragliding?
You'll see.
Okay, we will see what the ballooning has with paragliding.
My name is Mitja. I'm from Slovenia. I'm a physicist, and I also am becoming a mechanical engineer. So I am here today because Gaspar knows that I work for Nava, obviously, where we were interested into details of how ballooning affects your glider and paragliding in general. So before we start, there's one thing I have to say. This presentation may not be very typical presentation. The first thing is that I will be asking a lot of questions, and I expect to hear some answers from you. If you have them, feel free to answer them. If you have an opinion you'd like to share with me or with all of us, feel free to interrupt me at any time. So just don't hesitate, just ask, scream, whatever. Not important. So let's just start with the first question. So, what is ballooning? The reason why I'm asking you this is because, as it turns out, ballooning is very important for paragliding itself. I mean, it massively affects performance and safety of any glider, but many pilots still don't know what ballooning actually is. So, my question to you is, what is ballooning? And I dare you to answer. Anyone? What is ballooning? Top pilots. What is ballooning? Molek. What is ballooning?
So I have to guess, probably this effect that the surface of the glider is not so flat. It's like a balloon.
Yeah, close enough, that's more or less what I'm going to talk about, So, the first thing we have to realize is that in paragliding, there are no rigid bodies. What I'm trying to say is that everything you see, everything you feel, everything you can touch on your glider is soft and can be bent in any possible way you can imagine without harming or damaging the material. So everything is soft, nothing is rigid. And the pure mathematical definition, this is, by the way, the only hard thing I'm going to talk about. The pure mathematical definition, I will try to explain it now. So imagine you have imagine there's a glider flying towards you, right? Does anybody hear me? Yeah. So you should see a shape something like that, yeah? Now imagine you take only one cell of that glider, okay? Only one cell, it doesn't matter which one. Let's just assume they're all the same. Let's simplify it, everything. So you take one cell and you rotate it for about 90 degrees, and what you get is this. This is the exact airfoil of your glider, right? Yeah? Does everybody understand? Okay, so now what we would like to do is we take only one cross section here, rotate it again for 90 degrees, and what you get is a picture you should know it from before. You probably saw this picture before, right? So those black vertical lines are your profile ribs. Yeah, this green line is your cloth. It can be on top or bottom sail. It doesn't matter. They are more or less symmetrical. Not really, but close enough. And the distance between those profile ribs is, of course, your sail width. Okay. And the pure mathematical definition itself for ballooning says that ballooning is your arc, so your length of your cloth on the top sail divided by your sail width. That's pure mathematical definition. In reality, or not mathematically speaking, the ballooning is, like Jože already said, it's more of an objective measurement of this inflated thingy here between the profile ribs. Okay? Yeah? I mean, if nothing else, I just want you to know this. in the end. Okay, any questions so far? Good. So, yeah, ballooning is obviously important, or is it not? My question is, why is ballooning so important?
Because you cannot avoid it.
True, you cannot avoid it. We want to avoid it, but we cannot avoid it. That's one thing. Why is it important? Yeah, the same reasons all other things in paragliding are. So safety and performance. We always talk about safety and performance when it comes to paragliders. There's basically no other things. So, yeah, and when I say always, I mean like always, 99.9% always. So how does ballooning affect performance and safety at the same time, actually? Well, what you have to realize that the shape of the airfoil here, this is in reality only true on the profile mini ribs. In between the profile ribs, the shape of the airfoil is entirely different. It's not as nearly as it should be. It's completely different. And with a different airfoil, everything changes. Your performance change, your safety change, reopening after the collapses change, handling changes, therefore the safety, and yeah, everything basically changes. If you change the airfoil, you change the whole glider. Meaning, you can go from a very safe glider to a very demanding one, or in extreme cases, also to a completely different glider. So yeah, ballooning is important. That's why it is important. And there is one more thing, or one more aspect why ballooning is important. That's production. Because if you decide to, when cutting the material, you have to know how to cut the material. So this picture is supposed to show you how not to cut the material. This is the shape of your top sail, for example, if you wish. Now, if you were in production, if they were to cut the material in the straight rectangles, if they actually did that, what would happen? That's my question. What would happen if they cut the material into straight rectangles?
It wouldn't bend. It wouldn't bend.
No, it would bend. Why not? It's soft. It would bend, but not as it is supposed to. Why? Because you would get wrinkles. You can clearly see that here when it bends, you need more material. It doesn't bend here or here at the trailing edge, so you need less material. So the result is that if you cut the material into straight rectangles, you will get a very, very wrinkly top and bottom sail, which is what? Bad. Bad for performance and bad for safety. It's not good. Okay? So the reason why you want to know and predict and estimate and at least have a slightly clue of ballooning is because you have to know in production how to cut your material. If you do it wrong, it's bad. So in reality, I mean, what happens is that they, instead of the rectangles, they actually cut the material on this blue line, which you see is roughly the same as a rectangle here at leading and trailing edge, but dramatically changes. I mean, not dramatically, at least not in this picture, in between the trailing and leading edge. I will tell you a bit more about that just in a second. So, yeah, I mean, if you can predict or estimate the ballooning exactly enough, you can get rid of the wrinkles. Not entirely true. You can never get rid of the ballooning and wrinkles, but you can get close enough. I mean, not even close enough. You can just reduce them. So what are the critical points of ballooning? So where do you want to have minimum ballooning? And where is ballooning not so important? Answers.
About this from the beginning so far.
Yeah, obviously, like all the other things are. So you want to have zero ballooning at leading edge and zero ballooning at trailing edge. Why? Because if you have ballooning at leading edge, it costs you performance. If you have a lot of ballooning at the trailing edge, you have not so good handling. Yeah? Many of you should answer my next question. So if I have ballooning at trailing edge, that's bad for my handling. What do many companies do nowadays to reduce the ballooning at trailing edge? Exactly. Who said it first? You have a beer. Perfect. Yeah, mini rigs. I will show you in the second part of my presentation. Mini rigs reduce ballooning by factor 5 or thing. 5-ish. That's a lot. I mean, if you can do that, that's really a lot. So yeah, the next question is, how can we affect ballooning in the stage of development of a glider? Yeah, the most obvious thing we can do is we can introduce smaller cells. But does anybody know a downside of smaller and a lot more of cells? What's the downside of that? Yeah, price is a big downside. So if you have more cells, it's more material, it's more time in the production, so the bigger price. Like Phantom and, yeah, for example, yeah. Thicker airfoils. That's something that's maybe not so obvious as smaller cells are, but just believe me, it's true. I'm not saying it makes sense to make thicker airfoils, because you lose way much performance than you gain, but it is a solution. Yeah? And the second two possible solutions are, of course, reducing the inside pressure and increasing the span-wise force tension. Those two are a bit more available, if I may say that. But the problem is that, I don't know for you, but I, for example, don't want to fly with a glider that doesn't feel solid, that doesn't have enough inside pressure. I mean, maybe you want to, but I don't. So there's, again, a downside of this solution. And to increase the span-wise tension force means that you have to create a bigger curvature here. You need more material here at the ears of the glider, which is, again, not something you would want. Okay? It affects your handling, it affects your opening after the collapses and stuff like that. So it mainly affects the safety. But yeah, what I'm trying to say is that you can affect ballooning. It's just a question of how much and at what cost. So over the years, yeah, this is what changed basically. This is year, who knows what, 1980 probably. You can clearly see a lot. You can clearly see a lot of ballooning here, right? This is today Enzo 3. The profile here is clean. There is no ballooning thingy, no inflated things anymore. I mean, they are, but massively reduced. And how did they achieve that? Smaller cells, yeah. Increased span-wise force tension, for example, and of course other things which I'm not aware of, and yeah. So this is what we've gotten to today, and will probably improve in next years. So what can constructors do, or developers do, basically to change the ballooning, or to predict it, or to estimate it? Because obviously that's something they want to do. Because if they do that, they have a better glider than all the others do. Well, there are not many things they can do, actually. There are some software solutions available, not for free, but available, which do provide some kind of an estimation of what the ballooning will be, but at NOVA they were not really satisfied with those calculations, so they asked me to do better ones. Not raw. Okay. That's one thing. they do have some software solutions, and the other thing is that many still rely on their experience, feeling, intuition, which is okay if your feelings are good. If not, yeah, maybe it's too late for you. Ballooning part 2. For the second part, I have one condition to continue. And please listen very carefully. As I said, I did some modeling of this ballooning for Nova. And this part is supposed to be a secret. Kasper kindly asked me to show some stuff anyway, so I will do it, but under one condition. And that is, you put down all the cameras, no photos, no videos, no nothing. If I see anybody or Serial Cup team sees anybody, I will truly immediately stop and turn off everything.
Okay, thank you, Mitja, for this presentation. Usually in Serial Cup, more the presentations are pointed out how you would fly, how you should do it, that you will fly better. Today we went a little bit in another direction. Hope you enjoyed. It was a nice presentation from Mitja about actually one really important stuff which influence our glider and also development of the glider. So hopefully we will see more and more improvements like this, and the gliders will fly better and better.